I'm Caroline Metz. I'm applying to be a chem TA. My fun fact is that I was a camp counselor for this entire summer, so 10 weeks in all. Pretty crazy, pretty tiring. I actually just got back yesterday, so that's why this application is coming in so late. I didn't have any time until now to do it, but I really want to be one. And I want to be one because chemistry has always been my favorite subject, even since high school. I really appreciated chemistry because it was the one subject that I really had to work hard at and that I wouldn't always get the first time around. And one of my favorite teachers ever told me that he taught high school English because it was the one subject in school that he always had to work out. So he always understood when his students didn't understand it or when someone struggled with it, and he was able to be a more helpful and a better teacher because he had to teach himself tips and tricks, and so that way he could pass it on to others. And I feel the same way, and one of my end goals in life is to actually be a chemistry teacher. And so being a TA is kind of like similar, and I would love to have this opportunity and see if I have the capability and ability to teach others chemistry and to show them the passion that I have for this subject. So I'm going to turn my computer around and show it on the problem I have. So the problem I chose is an acid-base titration problem, but for this one I decided to do a weak acid with a strong base, which are pretty cool. And what's really important to remember with a weak acid strong base titration is that as the acid is being neutralized, a conjugate base is forming, and that conjugate base isn't water, which is how it normally is with a strong acid, strong base. So that conjugate base actually also affects the pH of the solution. So this problem is to find the pH of a solution containing 30 milliliters of 0.2 molar acetic acid after adding 15 milliliters of 0.1 molar sodium hydroxide. The first step for any titration problem is to write the equation out so you know what's going on in this beaker, what's going on in this experiment. So for this equation I have acetic acid, which is CH3COOH plus OH minus yielding to water plus CH3COO minus. The reason I don't have NaOH written out is because sodium is a spectator ion, and it kind of gets confusing if you have all of these different elements written in your equation. So this is like the basic what's really going on. The next step after that is to calculate how many moles you have of acid and how many moles you have of base. And you can do this by multiplying the volume by the molarity, because as you can see, you have units of volume right here canceling out to just give you moles. So you have 6 millimoles of acetic acid and 1.5 millimoles of sodium hydroxide. And for us, step 3, I wrote out explaining that you have a conjugate base being formed, which is why when you write your ice table, you need to refer back to this equation that you wrote in the beginning and set your ice table up under that. And recognize that the changes happening over here are going to happen on the right side of your equation. So what we have right here is we're beginning with these 6 millimoles of CH3COOH. And here are what we're adding, that 1.5 millimoles of sodium hydroxide. And so they're neutralizing each other, which is why it's being subtracted. But as that is being neutralized, the conjugate base is formed. So you end up adding those 1.5 millimoles and subtracting. So you end up with 4.5 millimoles of acid and 1.5 millimoles of the conjugate base. Your next step is to convert this back to molarity, because now you have an additive volume. It's not just the 30 milliliters of acetic acid anymore. You've added 15 milliliters, and that can affect your pH and everything, rather than just plugging in the moles. So I have my additive volume right here, and then you convert back to molarity by doing moles over volume. So I did 4.5 millimoles over 45 milliliters to give you a 0.1 molar of acetic acid. Same thing over here, but 1.5 over 45, and now you have 0.033 molar of the conjugate base. And your next step is to plug everything into the Henderson-Hasselbalch equation, which is your best friend when it comes to weak acids and weak bases. You'll use this for every single problem, so to find the pH. So the equation is that pH equals pKa plus log of conjugate base over log of the concentration of conjugate base over the concentration of your acid. And so the pKa of acetic acid is 4.76, and I went and just plugged and chugged and put everything into that. So you get 4.76 plus log of 0.033 molar, that's the concentration of this conjugate base over here, over 0.1 molar, which is the concentration of this acid, to give you a final answer of the pH being 4.28. Thank you.